welcome to your home school. This is your class 9 Mathematics NCERT or CBSE board, and this is your 4th chapter Polynomials with the 3rd exercise. Before starting our exercise, we are going to start with a division of a polynomials and remainder theorem proof. Okay, let's start our session today. So, we know divisions. Yes or no, children? We know normal divisions. Let's do some divisions here. So let me take 15 divided by 5 or 10 divided by 3. Okay. So how do you do this? 5 3s are 15, directly you will cancel. Or if you do division, what will be happening? 5. Okay. This is a dividend. This is a divisor. Okay. So now 5 3s are 15 and you get 0 here. Let's mention what all we know in this division. Look here, 15 I am dividing. So 15 is called as the dividend. With what you are dividing? That is called as the divisor. When you divide with a divisor, okay, what do you get here? Again, 2 more values you got. What are those? That is quotient. Quotient, and you have got here 0. That is what? That is a remainder. So, when I divide a dividend with a divisor, we get a quotient and remainder. Okay, this is a simple technique, children. So, again, how can you write this statement? Look here. If I say, what is the technique here? How do you get this 15, children? Divisor into quotient plus remainder, you get 15. Let's check it out. What is your divisor? 5 into quotient plus remainder 0. 15 equal to 15 plus 0 and 15 equal to 15. Yes, correct. How we are doing this division? How can we get here? The dividend is equal to divisor into quotient plus remainder. Right? Similarly, let's do one more example here. 10 by 3. Okay. So 10 by 3, how can you do, children? So now like this division, 3 3s are 9. 10 minus 9 will be 1. 10 divided by 3. When you divide, what happens? 3 3s are 9. 10 minus 9 will be 1. Where 3 is a quotient and 1 is called the remainder. When we divide 10 with 3, we got a remainder and quotient. Similarly, how can you get this? 10 is equal to 3 into 3 plus 1. That is 10 equal to 9 plus 1, 10 equal to 10. This is a basic technique, right? How can you remember, children, this one by a statement? Dividend. Dividend is equal to divisor into quotient. Divisor into quotient plus remainder. Divisor into quotient plus remainder. Okay, this is a small statement what we know till now in divisions. If we divide a number with another number, we get a quotient and remainder. So now we are going to discuss polynomial divisions. How can we do the polynomial divisions, children? Normal number, okay, that statement I can accept. What is that? Dividend equal divisor into quotient plus remainder. But now, when we talk about a division in polynomials, we should remember one statement. What is that? If P of x and G of x, what is P of x, children? Polynomial of x. And one more polynomial, G of x we can take. P of x and G of x are two polynomials such that degree of P of x is greater than or equal to degree of G of x. So what is that word, children, here? Suppose P of x is equal to 3x square minus 5. G of x is equal to x minus 2. Okay, now look here children, I have given p of x a polynomial. So observe the degree here. So x is a variable, right? Observe the degree here, the power. Observe the power 1 and 2. What is the degree of this polynomial? Highest power is called the degree. So degree is 2. Now g of x, what is the power? 1. What is its degree? 1. Okay, so what I am trying to say here, look here carefully, where if p of x and g of x are two polynomials such that the degree of p of x is greater than or equal to g of x, but not less than g of x. Understand the question carefully. This is 2, this is 1, or this might be g of x. Maybe with 2x square minus 3 I can divide. At the time both the degrees are same. What I can say here children, the degree of a polynomial p of x is always greater than or equal to. The degree may be equal or the degree may be greater than the g of x degree. That is only given here. Degree of p of x is greater than or equal to degree of g of x, and g of x is not equal to 0. If g of x is equal to 0, what happens children? There is no quotient, there is no remainder. Okay, then we can find polynomials q of x and r of x. What is q of x? Quotient. R of x? Remainder. Okay, let me discuss once again. If p of x and g of x are two polynomials where the degree of a polynomial p of x is always greater than or equal to g of x, and g of x is never equal to 0, that is not equal to 0, then we can get q of x and r of x. What is q of x? Quotient of the polynomial, and remainder of the polynomial is r of x. So polynomial with one variable we are doing, right? So the variable we write always inside. Yes, x, q of x, r of x. Simply we are not saying quotient, remainder we are not calling, right? Observe, there we wrote only quotient and remainder. How can you rewrite that statement children? Such that polynomial of x, dividend is what? P of x. Divisor is g of x. Quotient is not only q of x, and remainder r of x. So what is your important rule here? P of x is equal to g of x into q of x plus r of x. P of x is equal to polynomial of x is equal to another polynomial of x into quotient of x plus remainder of x. Let's see the division of polynomials now. How to do the division of a polynomial we are going to learn now, right? I have taken here two examples of division of polynomials. So look here carefully. Divide p of x is equal to x plus 3x square minus 1. And it is this p of x is divided by g of x is equal to 1 plus x. So what you need to observe here? First observe the polynomial, whether it is in a order or not. What do you mean by order here children? From highest power to the lowest power your equation should be. So here x power 1, x power 2 like this there. So in this what is the degree? Degree means highest power is called the degree. So highest power is 2, that is degree is 2. This equation, this polynomial is having a degree 2. So rewrite this polynomial. Arrange in an order first. 3x square plus x power 1, that is x, minus 1. Okay, then see this g of x. This one also in the same manner. X plus 1. Constant always should be last. Okay, first step when you are doing your division, you should arrange the polynomial from highest power to the lowest power. Then start division. How? Look here carefully. 3x square plus x minus 1 I need to divide. Right? I take like this. Okay. So now g of x I will write here x plus 1. How to do this division, children? Observe the first term of the dividend and first term of the divisor. You divide. So let's do that in rough part. So let me do this side. 3x square by x. It will be how much? Here x power 2 means 2x will be there. By x means 1x can be cancelled. So if 1x is cancelled, what is left here? 3x. So never try to cancel your x, children. You just cancel power. When you have only x, then you can cancel xx. Suppose if you have any power, you try to cancel power. The same way if you have here x cube, how can you cancel with x? X, you strike the cube part and then write 2. You have x cube means you will be having 3x. Right? In 3x, if you cancel 1x, 2x will be left. That means x square should be left above. Okay, understand and do the calculations carefully. So, what is our first term in your dividend? 3x square. First term in your divisor? X. If you divide, what you are going to get? 3x. That will be the starting term of the quotient. Okay. After dividing, what you have written here? 3x. Now, with this 3x, multiply the divisor. Start multiplying. 3x into x, it will be, x into x will be x square. 3x square plus into plus, plus 3x into 1, 3x. Okay. Now observe here, we have plus 3x square and here plus 3x square. Will it cancel? No, it cannot be cancelled. Then how it can be cancelled? When we subtract this equation with this equation, it can be subtracted. So now, what you are going to do? Take a minus sign here and here also minus. Why I am taking minus? When I need to subtract, you should multiply with the sign. And the sign will be changed. So here you have plus, plus into minus becomes minus, and here you have plus, plus into minus it becomes minus. So now forget this positive sign. Now look here, 3x square minus 3x square will be cancelled. X minus 3x will be minus 2x minus 1. Drag this one down. So understand here carefully, when you have an opposite sign, directly you can add these two in order to cancel. So here we have same sign. If we have same sign, we cannot cancel. Okay. So for that purpose, I have subtracted by changing sign. I have written here. Why changing sign? Let me show you here. 3x square plus x minus 1 there, and another is 3x square plus 3x. So, what is happening here, children? You need to cancel any one term. How can you cancel? When we subtract this, then we can be cancelled. Now, remove from brackets. 3x square plus x minus 1 minus into plus minus 3x square. Minus into plus minus 3x. So minus 3x square cancel. X minus 3x will be minus 2x minus 1. So observe here, like this if we do, same answer we get. So why we are multiplying or why we are changing sign means this is the reason. When we subtract, the signs will be changed. Okay, so when we subtract, then the negative sign we should multiply to the sign what you have inside the brackets. Minus into plus it will be minus, and minus into plus will be minus. Suppose if you have here minus sign, minus into minus it will be plus. right? This is the reason you are changing your sign here. Now, what is your next step? First step is completed. What about your second step? Again, you feel this is a dividend. The first term, take here minus 2x along with the sign. Whatever you have sign, you carry with the sign. Then what is your divisor first term? X. This x will be cancelled. What you are left with? Minus 2. That minus 2 right here in the place of quotient. So now what we need to do? This minus 2 multiply for this. Plus into minus, minus, x into 2, 2x. Minus into plus, minus, 2 into 1, 2. So now, minus 2x, will it cancels? No. So for that reason, what you need to do? Again subtract. Again subtract means what happens here? Minus into minus. Keep in your mind a minus sign and multiply. Or just you can write reverse also. Minus into minus, plus. Minus into minus, plus. When you are writing any sign, you should forget this sign, children. Understand carefully. When you are changing the sign, then you should forget this sign. Now what you can see here? Minus 2x plus 2x. Minus 2x plus 2x will be cancelled. And here also same manner. Don't say again minus 1, minus 2. Don't say. Minus 1 plus 2. Minus 1 plus 2 will be 1. This is your answer. What is your answer here? 1. So when we are doing a polynomial, we know p of x, g of x. Okay, what we are going to get here? A quotient. Q of x is equal to 3x minus 2. This is 3x minus 2. And remainder r of x is equal to 1. This is the way we need to divide polynomials. Okay, this is a division of polynomials. So one more example, let's see here. Okay, so look here carefully. Divide the polynomial 3x power 4 minus 4x power 3 minus 3x plus 1 by x minus 1. First thing what we need to do, we need to see the degree of the polynomial. See the degree of the polynomial, this is 4 and that is 1. So, when you are arranging your polynomial, highest power to the lowest power, you should arrange. So, let me start here. P of x is equal to 3x power 4 minus 4x cube. Oh, where is x square? X square is missing. Can you see x square? Not there. So how can we do? In division, don't neglect any term which is missed. You need to take that also. How can you take that? So look here, x power 4, x cube there. So what is missing? X square. 0 into x square. When you are doing division, compulsory you need to take. 0 into anything will be 0. So 0 into x square minus 3x plus 1. Okay. So now this should be divided by g of x is equal to x minus 1. Now write in this format, that is 3x power 4 minus 4x cube plus 0x square minus 3x plus 1. Okay, divided by, right? So let me write like this, and g of x is a divisor. I will write here. Yes. Now how to divide this polynomial? How to divide? Rule is same every time. First term of the dividend by first term of the divisor, you divide to get the quotient term. Right? So let's do in a rough column. Let me take here rough. First term in dividend 3x power 4. First term in divisor x. Now observe here. Here how many x you have? 4x you have. Denominator 1x. If you cancel 1x in 4x, how many x will be there? 3. right? That only you write. That will be 3x cube is your answer. This 3x cube, write it here. That will be 3x cube, right? Now multiply the number. What do you have? 1. 3 into 1 will be 3. X cube into x. X power 4. And plus into minus. Right? So 3x cube into 1 will be 3x cube. Okay? Now again, can you cancel here? You cannot cancel. Then you need to subtract. Subtract means just change the sign. Now 3x power 4 minus 3x power 4 will be cancelled. Now here minus 4 plus 3 how much? Minus x cube. Then drag one term plus 0x square. Now again same procedure it continues. First term in your dividend, first term in the divisor. So that will be minus x cube by x. So if this is cancelled, what you are left with? Minus x square. Write that one here, minus x square. Okay? So minus x square. Now again multiply this, children. Minus into plus, minus. X square into x, x cube. Minus into minus, plus. X square into 1, x square. So now again, sign will be changed. So look here carefully. X cube minus x cube plus x cube will be cancelled. And you are left with 0 and x cube. You can leave it. And this will be minus x square. Drag one term down. Then again, first term what you have? Minus x square by x. Minus x square by x will be minus x. That minus x, write it here. Now again multiply this. Minus into plus, minus. X into x, x square. Minus into minus, plus. X into 1, it will be x. Now again, both are minus. So again subtract, change sign. Cancel. Minus 3x minus x will be minus 4x. Drag the number down. Okay. So now again, minus 4x. Minus 4x by x, it will be minus 4. That minus 4, write it here. Now again multiply. Minus 4 into x will be minus 4x. And again minus 4 into minus 1 will be plus 4. So now minus 4x will it cancel? No, we need to subtract, means change sign. If you have minus, plus. If you have plus, write it minus. Minus 4x plus 4x will be cancelled. Minus 4 plus 1 will be, minus 4 plus 1 will be minus 3. Right? So finally what you got, children, here? Therefore, quotient q of x is equal to 3x cube minus x square minus x minus 4. This is your quotient, and your remainder r of x is equal to minus 3. So one thing observe here, if you have any number, then what can you say? This is not a factor. Suppose in your division you get your remainder 0, then that is a factor of the dividend polynomial. Okay, if you get an answer 0, then it will be a factor. If you get other than 0, then it is not a factor. Let's start your remainder theorem. This is the statement of your remainder theorem. That is, let p of x be any polynomial of degree greater than or equal to 1. So, let me take one example here, children. Let me take here p of x is equal to, this is any polynomial of having degree 1 or more than 1 I am saying. Suppose 3x square minus 4x plus 3 something you have. Okay, this is a polynomial of one variable, right? And its degree is how much? 2. How can you say the degree? Highest power is the degree. Here the power is 1 and here the power is 2. Okay, so what is the degree here? 2. One more example we take. Polynomial of x is equal to x minus 4. What is the degree of the polynomial? Here, what is the power you have for the variable? 1. Right? Here, the degree of the polynomial is 1 and degree of the polynomial is 2. So, now read the statement. Let p of x be any polynomial of degree greater than or equal to 1. Equal to 1, greater than 1. I have showed you example. And let a be any real number. A letter. A be any real number. Okay. If p of x is divided by the linear polynomial. P of x is divided by the linear polynomial x minus a. So understand here, a is any real number and polynomial p of x is divided by x minus a. X minus a is also a linear polynomial. Then the remainder is p of a. Then the remainder is a. You need to prove this. This is actually a theorem. They have given this and you need to prove this. Right? Understand the question carefully here, children. There is nothing there. If p of x is a polynomial, if a is any real number, then p of x is divided by another linear polynomial x minus a. Then the remainder will be a. You need to prove that. So let's start proving here. Right? So understand the degree of a polynomial. Here it is, what is the degree? 1. Suppose if I give you like this. Look here, children. So what is this? Do you have any degree? Yes, there. That is x power 0. X power 0 value is how much? 1. Then what you need to write for these type of polynomials? Yes, degree is 0 and it is also called as a constant polynomial. First, understand the differences between all the polynomials, children. Here, this is a polynomial of degree 1, polynomial of degree 2, polynomial of degree 0. Degree 0 and it is also called as a constant polynomial. Here, nothing there. Suppose if I write 4 or 4 and x power 0 is same. X power 0 means what? Degree is there. Degree is what? X power 0. X power 0 value is 1. 4 into 1, that will be 4. Therefore, we call this as a constant polynomial. When we have a degree 0, then that is called as a constant polynomial. So, let's start our proof here. Let p of x be any polynomial with a degree greater than or equal to 1. What is the given statement here, children? They have given that polynomial p of x is divided by linear polynomial x minus a. That means what? P of x is divided by the linear polynomial x minus a. Then what is this? This becomes the dividend. And this becomes the divisor. If we divide any dividend with a divisor, we are going to get quotient and remainder, right? So, according to that, we have seen now one statement. What is that, children? You can write that statement in two ways. One way is dividend is equal to divisor into quotient plus remainder. And another one is polynomial of x, p of x is equal to, what is a divisor here you have? X minus a. Divisor into quotient plus remainder. Okay, so what did they give? If a is any real number, and one more thing we need to observe, polynomial of x is its degree may be 1 or more than 1. But here, what is a linear polynomial given? Linear polynomial degree is equal to 1. See here, x power, what do you have? Nothing. Nothing means 1. Linear polynomial degree is equal to 1. And observe here, if this is 1, then what will be the remainder? Remainder degree will be, look here, r of x. Remainder r of x degree will be 0. Why 0, children? It will be less than the g of x. Okay, this is a divisor. I may call it as a g of x also. The remainder degree is always less than g of x. Okay, so now what I can say here? Degree 0. Degree 0 means I may write r of x is equal to r. Why? It is a degree 0 you have. Degree 0 means what? It will be a constant polynomial. Instead of a constant polynomial, I will write r. Okay. So now replace this with the given if a is any real number. So what do we do, children? This a will substitute in the place of x. Ready? P of a is equal to a minus a into q of x plus, what is the degree of rx is? R. Let me write it as r. It is a constant polynomial, right? So a minus a will be 0 into q of x plus r. 0 into anything will be 0. So finally what you are getting? P of a is equal to r. Observe the final statement. Then the remainder is P of a. Remainder is r. Remainder is P of a. This is nothing but remainder theorem proof. Once again we discuss here, children. Statement. What is the statement? Let P of x be any polynomial of degree greater than or equal to 1. And let a be any real number. If P of x is divided by x minus a, we get a quotient and remainder. What do we get, children? We get a remainder and a quotient. So, divided by the linear polynomial x minus a, then the remainder is P of a. What I need to prove? I need to prove remainder is equal to P of a. So, now we know that dividend is equal to divisor into quotient plus remainder. That is P of x is equal to g of x into q of x plus rx. When polynomial is divided by linear polynomial x minus a, we get a quotient and a remainder. So, linear polynomial degree is how much, children? Is 1. Then what it will be the reminder's degree? Remainder degree is always less than the g of x. Remainder degree is 0. Degree is 0 but not the value. Understand here question. Remainder degree is 0. Then it becomes a constant polynomial, or I can take remainder r of x is equal to r also I can take. Therefore, if a is any real number, substitute that a in the place of x. What you are going to get? A minus a is 0 into qx plus r. In place of r of x, I have written here r. A minus a will be 0. 0 into q of x is 0 plus r. Therefore, finally, r is equal to P of a. Therefore, remainder is equal to P of a. That's it. Hence, it is proved. This is your simple remainder theorem, children. Okay, now we have seen these two problems in division method. We found the quotient and remainder. Similarly, we are going to use another method, that is by using remainder theorem. We are going to do the same thing, but we get here only remainder. We won't get quotient by this method. So let's see this method. What is this new method? by using remainder theorem. Directly within 2 lines you are going to get your answer. P of x is equal to x plus 3x square minus 1. G of x is equal to 1 plus x. First step is same. Arrange the terms carefully such a way highest power to the lowest power. That is 3x square plus x minus 1. G of x is equal to x plus 1. Now, how to do children here? Find the 0 of the polynomial. How will you find 0 of the polynomial? When we equate the divisor with a 0. That makes plus 1 if it goes other side. It will be minus 1. Substitute this x value in P of x. So let's write here. Substitute x is equal to minus 1 in P of x. That is P of x is equal to. Again, if you want, you can rewrite the polynomial or directly you can substitute. In the place of x, I will write minus 1. That is minus 1 plus 3 into minus 1 whole square minus 1. Minus 1 2 times if you multiply, what happens? Minus into minus plus 1 into 1, 1. So that will be 3 into 1 will be 3 minus 1. So now minus 1 will be minus 2. 3 minus 2, 1. That makes P of minus 1 equal to 1, or I may write it as P of A is equal to R. P of A is equal to R, where remainder, R is a remainder, that is R of x is equal to 1 is your answer. By division method, what you have done the same problem, you got the same remainder. Second problem, P of x is equal to 3x power 4 minus 4x cube minus 3x plus 1. And G of x is equal to x minus 1. So, this one also we do by using the remainder theorem, and we are going to find the remainder. So, here P of x is equal to 3x power 4 minus 4x cube minus 3x plus 1. No need of writing the missing power. Whereas in division method, we write the missing power with a 0 multiple. Okay. Now, G of x is equal to x minus 1. What we need to do first step in this method? Find the 0 of the polynomial. That is, G of x is equal to 0. That makes x minus 1, 0. Minus 1 send the other side. Plus 1. This x value substitute in P of x. Substitute x equal to 1 in P of x. That means P of x is equal to 3x power 4 minus 4x cube minus 3x plus 1. Okay. Now 1 substitute here. P of 1 is equal to 3 into 1 whole power 4 minus 4 into 1 whole cube minus 3 into 1 plus 1. That will be 3 minus 4 minus 3 plus 1. See your children, 1 if you multiply 4 times, 1 only. 1 multiplied 3 times also, 1 only you are going to get. So now plus 3 minus 3 cancel. Minus 4 plus 1 will be minus 3. Therefore, P of 1 is equal to minus 3. This is nothing but R, or you can write it as remainder of x is equal to minus 3. When you divide the polynomials, you are going to get the remainder minus 3. Do you remember, children, in your division method also we got the remainder minus 3. There we got quotient, but in this method we won't get the quotient.